to a short introduction to stitching with XuvTools and the grid layout tool. I will start by adding an LSM time series to the project. Then I will calculate the thumbnails. Since thumbnail calculation can take quite some time, we will fast forward here. As you can see, when there are no stage coordinates available, the stitcher will place the tiles in a regular grid. This grid is as good as any. It is not correct. Therefore, we use the grid layout tool. The grid layout tool has several options. It allows you to set the scene voxel size in case it was read incorrectly from the stacks. Also, it allows you to mirror stage axes, the X, Y, and Z axis, in case your microscope is wrongly calibrated. You can choose among several typical grid layouts, and you can set an overlap between neighboring stacks in %. Also, it allows you to define the grid size in rows and columns. Now, from visual inspection, we can tell that there might be 5 rows and 4 columns. So let's apply this with the grid layout tool and apply the grid. Now we can see this looks a lot better. When we zoom in, we can see that neighboring stacks have an overlap. So again, open the grid layout tool and choose an overlap of 10%. Apply the grid again. Now again zooming in, we can see that now neighboring stacks match quite well. But something else is wrong. Since our microscope was wrongly calibrated, the y-axis is mirrored. Again, open the layout tool and choose mirror y-axis. Finally, we have found the correct stage positions. Now, in X and Y, neighboring stacks match quite well. From these almost perfect stage coordinates, we can run the stitcher. Let's set a high similarity threshold since we want a very good stitching. Then run the stitcher, and this time choose the option the stitcher will use current tile coordinates to simplify the search. Only use this option if the tile coordinates are almost correct, but since we use the grid layout tool, we know they might be very close to the perfect positions. Then start the stitching. Now is a good time for getting a cup of coffee. Once the stitching is finished, we can decrease the similarity threshold until we get a complete overlay. Finally, we have reached a complete overlay. The stitching was a lot faster and needed less memory than if we would have used the exhaustive search. Therefore, the grid layout tool is mainly efficient for speeding up the search and reducing memory needs. Finally, we can save the stitching, and we're done.